In this video I'm going to be going through some questions that relate to shear. We've got some bolt shear and ribbon shear. So we've got questions from 2007 to 2014. So two of these are multiple choice, but I'll go through the working out for you. So the 2007 question 8, what we have is triple shear. Wait, what kind of shear is this? Let's have a look. If we go down from the top, we say that this whole part here is going left, 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 right. At this point here, there is a change in direction. At this point here, there's a change in direction. Okay, it's now going right, 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 right. It's still going right until there's a change in direction. And then here it's going left, 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 left. So this is in double shear. There's two changes in direction. There's a change in direction here and here. So the area that we would use for our calculation would be 2 times the cross-sectional area of the bolt. Now, if I can tell you that 2 cuts of the bolt require 40 kilonewtons, what would we expect from 1 cut of the bolt? 20, yeah? So this is going to take 20 kilonewtons. We checked the answers beforehand, that should be B, right? I don't have the question on the board, so I actually do put it on the board for other people. B is the answer. Okay. So this question here, ribbon shear. So what we're looking at here is we need to find the thickness. This value here is what's unknown. Right? That's what we're finding, the thickness. I sometimes call that H. Right? H is a common terminology to use for thickness. Now, to find the key thing that we need to look at here is, well, we say, first of all, we know stress equals force over area. So what we want to do is we want to rewrite that so we can have area equals force divided by stress. Now in this case, I could write the little SH just for shear. We don't really need to do that. But the only time we don't use this stress equals force of area is bending stress. Bending stress is the weirdo. Right, we haven't got to bending stress, so we don't need to worry about that. Now, we need to calculate this area. Now when we find that area will be what I call the ribbon area. It'll be the perimeter multiplied by the thickness. Yeah, like a ribbon. Yeah, I'll colour it in just to make it clear. This is the area that I'm interested in. Okay, so what we're looking at here, so we've got stress equals force over area, area equals force divided by shear, so our force is 290 newtons, right? So I'm just going to bring that here. So area equals 290 newtons divided by the shear. Now, we could convert megapascals into pascals, right? That's what Copeland suggests we do. Me, I don't like to do that. Practicing engineers, they just know that megapascals and millimeters go together. We go together like megapascals and millimeters squared. So what I can do is 290 divided by 9.67 gives me some answer. It's going to be about 30. I don't know exactly. I have to get my calculator out, and I've got a bad calculator now. I went to an iPhone, and the calculator is not very good. So sometimes I'm going to need help from you guys. 290 divided by 9.67 equals 29.98. Didn't I say it would be nearly 30? Okay. That is the area. Look, really that just rounds up. But so that's in millimeters squared. Now what we need to do though is we need to find this thickness. So what is the perimeter? So our area is equal to, I'll just bring this over here. Area is equal to perimeter times height, right? Our perimeter is equal to 5 plus 5 plus 5 plus 5, right? So our perimeter is equal to 5 plus 5 plus 5. It's equal to 4 times 5 times height, right? Which is equal to 20h. Okay, so if we know that our area equals 29.9, we just call it 30. 30 it equals 20h. What we can do is divide both sides by 20, and we can say h equals 30 divided by 20, which is going to be equal to 1.5 millimeters thick. 9.5, so I've done something wrong. Let's have a look. Everyone loves being wrong on camera. Let me go to the question. 290 force to, okay, so I've said I move that up here. I swap those. So force divided by area, 290 divided by 9.67 equals that. The area is 5 plus 5 plus 5 plus 5, so that's 5, 10, 15, 20, so it's 20. So divided by 30, area equals perimeter times height. Area equals perimeter times height, so I take 30 divided by 20, divide both sides by 20 to get rid of it. Divided by 20, 1.499. Gonna have to check. Sorry, everybody. 2008 is the one paper we don't have answers for. It's probably right. Yeah, okay, we don't have answers for 2008. I was looking at the wrong thing. Okay, so I'm going to assume that's right. We don't have answers for 2008. I'm fairly confident, having gone through it twice. Okay. Okay, so this is a 4. This is 4 millimeters thick this time around, right? So just making that clear, that's 4 millimeters thick this time around. What we need to do is the same concept that we're looking at here. This time we need to find the force. Let's do the thing again from the top. Stress equals force divided by area. What we've been given the stress, we can work out the area, so we need to write the force. Force equals A times stress, right? So what is our A equal to? Our A is equal to we've got half a circle plus 10 plus 10 plus half a circle. Yeah? Now if I have 2 half a circles, that's the same as 1 circle. Yeah? 2 halves is the same as 1. So I've got a circle that has a diameter of 10. Now everyone likes to use pi r squared, but the fact is you don't really get radiuses very often as engineers. You usually get diameters, to be honest. Right? You usually get diameters. So we can say that this area, so the perimeter of the circle, the circumference of the circle equals pi d, which is equal to pi times 10, which is equal to 31.4. So we've got that equals these two parts, and then we have two 10s, right? So we have the total perimeter, P total, equals 31.4 plus 10 equals 51.415, right? 51.416 is accurate enough for us. So that means our area is going to equal P total times H, which is going to equal 51.416 times 5. No, it's times 4. That would give me a wrong answer. Look, it's always worthwhile, and for those of you who watch several of my videos who have heard me say this lots and lots of times, it's important to remember that in a question, it's different if it's multiple choice. If it's multiple choice, you just got to get it right because they've limited the answers down to a certain number. But if there's working out, they will do whatever they can to accommodate you if you've just made a clerical error, right? Real engineers, you get checked several times. So, by various bosses will check your work. So area equals this many millimeters. So it says force equals area times stress. So F equals 206 millimeters times 600 megapascals. Remember, we can use those units. They're megapascals and millimeters. We go together like megapascals and millimeters squared. I get an answer. I get a force equals 123.4 times 10 to the 3 newtons, or 123.4 kilonewtons. Person who checked that, is that right? It's multiple choice, so we should be able to see if it's one of our options. D, yep, that's right. Moving on. D is the answer. Okay, last one. This one's pretty easy, I think, if you understand the concept of double and triple shear. So when we're talking about... Okay, in this video I'm going to be continuing on with some questions from past HSCs on shear. So it's mostly, these are all bolt questions, no ribbon questions here, but we'll go through them quickly. So the 2016 question, it's question 24D, it's simple shear, so it's single shear. There's only one change of direction. So when we take out, often in the HSC, I'm not saying always, but often it's double shear. So you should always be worried if you're not at least using double shear. Okay, so in this question, what we've got is, I've written this in the format of data. I like this format where you just write down your information. You're saying, Okay, from the question, I've looked at the question, and what I've done, I'll show the question to my students in the room. I didn't do 2014. I'll quickly do 2014. So here, let's look at our changes in direction. So let's say they're going this way. This one is going right, left, right. How many changes of direction was it? It was a change of direction here. 1, 2, 3. 3 changes of direction. So it's in triple shear. I think that makes the answer C. Okay. So back to this question. This is a good way of presenting information. It's in single shear. Right, I've said data, F. What I've done there is I've taken my information from the drawing. That helps the markers know what I'm doing. Right, there's a lot of words there, and I'm trying to deconstruct it and make sure that I haven't. Sometimes you've got to check, like, for instance, there might be the word 3 wires on the start. That's very, very easy to miss. And so at least here you've shown people what your assumptions were when you started. I apologise for the camera to the world's largest whippersnapper. It's just outside of my control. Stress equals force over area. You don't control the garden as you will one day. Force over area. Okay, so what means our formula is going to be area equals force divided by stress. You can do the little triangle if you're that way inclined. You can say stress equals force over area, and you can cover over the one that you want to find. That works for some people. For me, I just can use algebra, but somewhat works for some people. Okay. So we're finding the area, but so what we're going to do is we're going to apply this formula. So our force is 2 kilonewtons, but because the factor of safety is 2, we're going to add in here times the factor of safety. So we're going to say 2 times 2. Hopefully I've got the right information. 2 factor of safety is 2. Okay, this is not really how you do factor of safeties in like the working world, but it works for HSC because you're not there yet. The stress is given to us as 56 megapascals. Now we're in kilonewtons. Remember, we don't want to confuse things. So kilonewtons is times 10 to the 3 times 2, right? Kilonewtons, we have to use newtons, right? We can use megapascals, we can use millimeters, but we have to use newtons. Otherwise, our answers will be wrong. So what we're going to have is 4,000 divided by 56. Again, I used to have a good calculator, but now I don't. 4,000 divided by 56 equals 71.43 millimeters squared. Now, the question is asking us for a diameter. So what we need to know is engineers use area equals pi d squared on 4. Now, if you're one of those people who wants to use radius, that's fine. I can tell you that I remember being in high school, and I remember my teacher saying over and over and over again, use pi d squared on 4, and I didn't listen to him. Not until I was working did I actually start doing that. So I'm going to rewrite that as 4a equals pi on d squared, right? So then I'm going to take the pi away from both sides. I'm going to divide both sides by pi. And so I've got d squared, so I can remove the d squared by square rooting that. So I can say d equals the square root of 4a over pi. I unfortunately can't do that in my calculator. Someone already done that? We're looking at 2016. It should be like 9.5 or something like that. Right. Now, generally, you can't buy a bolt that is, well, a student's working on calculating that for me. You can't buy, generally, a 9.5 millimeter bolt as a rule. So if you were designing this, what you would do is you'd round up to, is it right? Yeah. You'd round up to a 10 millimeter bolt. But that's not what they asked. If you wrote 9.5, they're not going to take any marks off. Typically, this question here, they specifically said these are the bolt sizes that are available. You probably can actually buy 9.5 millimeter bolts. When you start to get to more irregular things, it becomes a bit harder. Okay, so the next question is our 2017 question. So we've got, this is question 26b2, and I've taken the information. This one was just written as a word, there was no picture here. So they told us that the diameter is 20, the UTS. Now it's important to remember that when it comes to shear, right, we'd have a shear strain, so a stress strain diagram. Now it's important to actually remember that the stress strain diagrams do actually look different for every, not just for every material, but also it looks a little bit different in tension than it does to shear, than it does to compression. You don't need to worry about that. But the point is, normally we limit our results to here, to something about that level, right? We base it on the yield stress. But when we're shearing, when we're trying to punch a hole through something, or when we're trying to tear bolts apart, we only care about, especially when we're punching holes, all we care about is the UTS, the ultimate tensile stress. So that is a question that can come up worth knowing, right? So we've been given UTS here, right? So the values we've been using previously would have been UTSs, they just didn't spell that out for us. Okay, so what we're saying, I write in my formula, stress equals force over area. If you write that down every single time, it sticks. I was teaching year 8 maths the other day, and I was surprised they didn't remember area equals 2 pi r. And it's just one of those things where you take for granted that what people know. Okay, so stress equals force over area. Now, what are we looking at finding here? So we've been given the area, we've been given the stress, so we're going to be finding force. Force equals area times stress. So what is our area? Well, let's calculate. Our area is equal to, let me just get this question up. A diameter hole, it is punching shear. Sorry about that, I said there was no punching shear question. It's a ribbon shear question, right? So we're punching a hole like this that's got a diameter of 20. So we're going to be looking at a ribbon area. I try not to use the term punching shear except for concrete, but it can be helpful. So what we need to do is we need to find the perimeter of the circle and then multiply by the height. So the perimeter times the thickness, right, is how we write that. Perimeter times height. So the perimeter is going to equal to pi diameter times height. So that's going to equal to pi times 20 times 0.5. Okay. 5 times 20 is 100, so it's going to be 10 pi, presumably, right? Yeah, half times 20, 10 pi. So that's going to equal 31.4 millimeters squared. Now, it's not unreasonable, it's not unusual to get those sorts of answers in the HSC because often they want to make life easy for you. They don't want to actually trick you on the calculations. So F equals 31.4 times 110. If I was better at maths, I'd be able to figure that out. But it's probably going to be like 341 and a bit. Call it like 5. We'll get the calculator out. Yep. Yep, we're good? Oh, maybe times 10? Oh, 110. Okay, thank you. 3, 1. I'm now going to type it in myself. This is the worry about using estimates is sometimes it's easy to drop a digit. Anyway, pretty close. Okay, so that's our force, and they have rounded off in the answers. They have just said 3.46 kilonewtons. So my maths would have been okay. So that's that one. We're now at this question, 2019 question 27B. So it shows us this picture, and it's a big question, right? So it takes up the whole page, this question. And, well, not the whole page, but it takes up a lot of space. And what it's asking is, it's saying, give us all this information. It tells us the Young's modulus, it tells us factor of safety, it tells us the total force, it tells us the UTS, so the ultimate tensile strength. Now, keep in mind, we don't actually want the ultimate tensile strength, we want the ultimate shear strength, but we're going to use UTS because that's what they provided for us. Now, the question is, what kind of shear is this in? Now, I don't think I marked this, but I think a lot of people didn't realise that it was in double shear, right? So they didn't realise that when we're thinking about, well, if this is being pulled, right, if I tied a rope on this and pulled it, I'm going to have a reaction that way and a reaction that way. So how many changes of direction have there been? Yeah? How many reactions? It was going back, 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 forward, 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 back, back, back. How many changes of direction were there? 2. So it's in double shear. Okay, so what we're going to write is stress equals force over area. If you just write it down over and over again, it will become second nature. There's a reason why I say it's the second most important thing you need to know on the subject to not embarrass me. The only time it doesn't apply is for bending stress. Bending stress, that's a more complicated formula. We'll worry about that later. Right? Now, so when we have a factor of safety, we're just going to multiply on there as well, factor of safety. We did that. In this video, I'm going to go through the 2019 shear question. So both this question and the 2020 question, they're both double shear. So it's bolts in double shear. And when they provide the information, so this picture, there's a picture that takes up a quarter of the page and then a table of information. What we have is, we have the Young's modulus of 240 gigapascals, the factor of safety, the force, the UTS, which is the ultimate tensile strength. Now keep in mind we actually want shear strength, but in this case we can use the UTS as the value that we want to use for shear. In a previous video I just talked about why we want the UTS rather than the yield stress. And I've already worked this out, but I didn't have the camera, so I'm going to go through it now without and just go through it again. So we start by saying, well, stress equals force over area, right? We really want to drum home that formula. So once we have that, well, we want to add to it a little bit, because what we want to say, so it's technically shear stress, but that doesn't matter, it's the same formula. Stress equals force over area. But what we have here is we have two changes of direction. So we're going back, 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 forward, 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 back, back, back. There's two changes of direction. So that means we're going to double the area. We're going to have 2 times the cross-sectional area. We also have a factor of safety of 5, so we're going to multiply that by 5. So we're then going to rearrange this formula. We're going to swap these two values, and we're going to get, so A equals F times 5, or I can write this as factor of safety, times 2 shear. Right. So we're just moving the A. We're not doing anything to the 2. So what we then get is our force, which is 30. Oh, we have to figure out the area first before we do anything. No, we're calculating the area. That's what we're doing. Okay, so we get our force equals 3.5 times 10 to the 3. Because remember, it's in newtons. We have to convert newtons to kilonewtons to newtons. Then we're multiplying by 5 for the factor of safety. We've got our area. Oh, and then divided by 2 shear. 2 times shear, the shear is provided as 240, the UTS. And so what we're going to do is, I've calculated that already, gives us 36 millimeters squared. And then if I find diameter, I can use diameter. I had previously worked this out. You know, I'll work it out again. When I'd written that there, I'd already done it. So if I know that area equals pi d squared on 4. Now most people like to use something to do with radius. I find it easier just to do this. So what we can do is we can multiply both sides by 4 and cross that out. Then what we need to do is we're going to divide both sides by pi, so they cancel out. And then what we want to do is we want to take the square away, and that gives us diameter equals, diameter equals the square root of 4 area on pi. Now, some people actually just memorize that. Some people say, you know what, that's for the formula, I'm going to remember it. Rather than using pi d squared on 4, they just instead they reverse and they say that d equals root 4a divided by pi, or root 4a on pi. If that works for you, great. That's the part that you generally need. Well, you need both. Anyway, so we then plug in those numbers. So what we get is d equals 4 times 36 divided by pi, take the square root of everything, and that gives us an answer of 6.8 millimeters diameter. The problem is that this question specifically says it gives us a range of bolt sizes we're allowed to use. I just have to wait for my computer to wake up. Sorry. I tried to have everything set up before I started. Okay, so it had to be 5, 6, 7, 8, 9, or 10 millimeters. And sometimes you might even not have an option of like the odd numbers. You might have 5, 6, 8, and 10. That might be a more reasonable choice. Anyway, the point is we can't buy a bolt that is a 6.8 millimeter bolt. So if we can't buy a 6.8 millimeter bolt, what we have to do is we have to choose to go up or down. If we go down, we'll be reducing our allowable area. We'll make the thing less safe. Again, try and think of it in terms of if you had a chain, would you want the chain to, that's going to hold your weight? You're on a roller coaster ride. do you want that chain to be bigger or smaller? And in our case, we want it to be bigger. So we're going to say use 7mm diameter bolt. Okay, so that gives us the answer for the 2019 paper. I should have taken a photo, but I have taken a photo of the board before I cleared it off. Now, last question I'm going to do is the 2020 question. What we can see here is we have this sort of, we have a yoke that is connected to a rod, and that rod, the pin is going through, the rod is going through that pin. So what we have is 3 different pieces of metal. What we're interested in is this thing here, a rod with a diameter of 55 millimeters. It's actually, funnily enough, it's in Homebush. It's at where the HSC markers meet up, the actual photo that they took. So what we have here is we know that the diameter is, I have diameter 40, and I've got 55 there. So I'm going to check that what I've copied, sometimes what I copy onto the board, it says 40 diameter, and 50 shear is the shear. Okay, so this is in fact 40. That didn't feel right. I wonder if I used the right value there. I guess I took my number here rather than that picture. Okay, so what we're going to say first is we always say stress equals force over area. We'll start with that. Now they've given us the diameter, so that means we probably have our area. We've given us the stress, so what we're going to be finding is force. So we're going to rewrite that equation. We'll say force equals area times stress. Okay, I had in another video I had drawn a triangle and said, hey, that's useful. Normally I get my algebra pretty right. Unfortunately, when I was recording this, I did mess up my algebra. So, even me coming back from lockdown, it's been a while since I've done some stuff on the board. So, what we're going to need to know is we're going to need to know the area. So to find the area, we're going to take the area of a circle is pi d squared on 4. And so we say pi times 40 squared on 4. Now the thing to remember though is, because this is in double shear, now when we say it's in double shear, we can say, well, if this is, we'll call this left and we'll call that right. So we're going left, 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 right, right, right. So left, 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 right, 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 left, left, left. So we're changing directions twice. So it means that what we're going to be calculating is that circular area and that. If we have a bolt, we're taking 2 cross-sectional areas that are being cut. So it means we need to multiply our area. Area equals this times 2, which is why I've written it like that here. If you type that into the calculator, you're going to get area equals 2,513 millimeters squared. And we like millimeters, we like megapascals. What we don't like is kilonewtons. We want to make sure that everything else is in SI units except for millimeters and megapascals because of the song. Okay, so if we just take force equals area times stress. Area is this, and the stress we've already said is 55 megapascals. We don't need to do any conversion, we can just multiply those numbers, and we get a big number. We get 138 something thousand, right? If we then can convert that number into 138 kilonewtons, and that's our answer.